Okay, so make sure you have full attention on this part, okay? Because now we're going to combine everything we learned up to now together, okay? Because so far, everything is just little pieces, right? So at the beginning, we talked about radian, right? Changing degree in radian, okay? We talked about angle could be positive, could be negative, okay? Just a quick review. And then we mentioned about reference angle, right? Which one is reference angle? Area and arc length, we don't need that here, okay? For the question that we're going to do. And then we mentioned the three pairs, sine, cosecant, cosine, secant, tangent, cotangent, right? And then we go over the positive, negative signs. So all those little pieces are like the little pieces of the puzzle, right? Jigsaw puzzle. Now we're going to put them all together and then try to solve the question in the following page, okay? So that's why we spend a lot of time making sure every little steps, okay? You're all good. So here, the angle that we're going to deal with is mostly 30, 60, 90, 45, and 90, okay? So, and we will be using radian most of the time. So we need to change them to radian, okay? Thinking radian as well. So what is 30 degree in radian, Daniel?
Pi over 6.
Yeah, pi over 6, okay? Make sure you write it down. And then, or you just remember it, okay? Even better. Jenny, what about 60 degree in radian? Jenny, what's 60 degree in radian?
Is it pi over 3?
Yeah, very good, okay? Pi is 180 degree, right? You need to slice it into 3 pieces. So pi over 3 to make 60 degree. Okay, 90 degree. 90 degree, Nick.
Pi over 2.
Yeah, pi over 2, okay? And then we have the 45 degree. Sophie?
Pi over 4.
Yeah, pi over 4, okay? You cut the 90 in half again, so pi over 4. So we'll be using these angles, okay, a lot of times. So you look at the question here, this page in degree, right? But after that, it starts to have radians, okay? Look at question PQR, those are radians, right? So make sure you can work in degree and radian, okay, interchangeably. So let's look at the 30, 60, 90 first. 30 degree, right? So pi over 6. So we'll put the angle here. Okay, so everyone can write it in your picture as well. Pi over 6. Okay, it's the smaller angle, right? Compared to the other side is the pi over 3. Okay, pi over 6 is the smaller one. Pi over 3 is the bigger one. Okay, and the largest one is the pi over 2. Okay, so of these 3 sides, the longest side should be opposite to the pi over 2, right? Because it's the biggest angle. Think about the door, right? When you have a door, right? The opposite side is this length. If I open the door wider, then you should get longer. Make sense? Right? This angle, let me change that. Angle number 1, angle number 2, right? Angle number 2 is bigger, so its opposite side should be longer. Angle number 1 is smaller, right? Smaller, and then it will be shorter, okay? If it's larger angle, it will be longer side. So keep that in mind. So if it's pi over 2, it's the largest angle, you will have a side of 2. Okay, and then the smallest angle is pi over 6. So it's opposite side, right? The one that's opposite to it will be 1, right? 2 is bigger than 1, right? And then the last one, you could use the Pythagoras, okay? Then you will figure out the middle side, right? The middle length will be √3. So 2 is not difficult to misplace, okay? It's the 1 and √3. Usually people mixed up the place, okay? And that will make your question wrong, okay? So just remember the shorter side, right? This is the shorter side. It will be the 1. It'll be the √3 is the longer one. Okay, you put √3. The 2 is the hypotenuse, okay, the longest. So this is called special angles. Whenever you have these 3 angles, pi over 6, pi over 3, pi over 2, the sides will be fixed. Okay? Sides, for special angle, the side ratios are fixed. Okay? These are the common ones. So you need to remember their place. So for example, if you look at the question on the right side, okay, sine 60. So sine 60, you need to look from the green number, right? Sine 60. So sine 60 is opposite over hypotenuse, right? Sine is opposite over hypotenuse. So Evan, what is sine 60 equal? What over what?
Opposite of hypotenuse.
Yeah. So in the picture, what number over what number?
1/2.
You need to look from 60 degree. Which one's the 60 degree? What color?
The green one.
Yeah, the radian, pi over 3, right? So you need to look from pi over 3, opposite over hypotenuse.
√3/2.
Yes, okay. So you need to look from the right place. Okay, let's try another one, all right? Let's say if the question is cotangent of pi over 6. Okay, please raise your hand if you have the answer. Okay, cotangent pi over 6. So pi over 6, you look from the angle pi over 6, and then you think about cotangent. Cotangent is the reciprocal of what? And then you need to flip it, right? Cotangent is what over what? And then you make sure you look from pi over 6. Okay, at the beginning, it might take a long time, okay? But once you get used to it, you'll speed up. Okay, Jenny, what's your answer? Cotangent pi over 6.
You asked me, right?
Yes,
I got √3
√3. Okay,
over 1, but
over
it's
1.
the same thing as √3.
Okay, so it's which side over which side? The name.
It's adjacent over opposite.
Very good. Okay, cotangent is the flipping of tangent, right? So TOA, you need to flip it, right? So adjacent over opposite. Adjacent is √3. Opposite is 1. So you just write √3. Any questions? Those of you haven't raised the hand, do you have questions? Okay, raise your hand if you understand how we get the √3. Jocelyn, do you have questions how we got the √3? Okay, so that's how you use the picture, right? And then sine, cosecant, cosine, secant, tangent, cotangent. That's why I ask every one of you, right? Make sure you can pair up the right sides. So similar for the power 4. Okay, so power 4 will be this one. For power 4, it's an isosceles triangles, right? So if it's isosceles triangle, then their two sides should be the same. So ratio will be 1 to 1. All right, so if it's 1 and 1, the last one, you can use Pythagoras theorem and you find out the hypotenuse will be √2. So these three numbers are fixed. Okay, whenever you see power 4, you have to use these numbers as the sides. All right, so for example, like tangent 45 degree. Okay, what's tangent 45 degree, Eric?
How, wait, it's 45, is it just 1?
Because it's what over what?
1 over 1.
Yeah, opposite is 1, adjacent is also 1, so give you 1, right? Now let's try a different one, okay? So let's say this time we have secant. Okay, secant of pi over 4. Okay, so if you have the answer for that one, secant power 4, please raise your hand. Secant pi over 4. Pi over 4, same as 45 degree. So think about secant. Secant is which side over which side? Secant power 4. Okay, if you got the answer, please raise your hand. All right, Callum, what's your answer?
It's square root of 2 over 1.
Okay, very good. Square root of 1, which is same as,
Square root of 2.
yeah, secant is the reciprocal of,
Cosine.
okay, so it should be what over what? Which side over which side?
Adjacent over hypotenuse.
That's cosine.
Oh,
Secant
secant.
will be-
Hypotenuse over adjacent.
Yes, very good. Okay, so you take the hypotenuse. Hypotenuse is √2. Adjacent is 1, so √2 over 1. Okay, those of you haven't got it yet, okay, let me know if you have questions. If you understand up to here, can you please raise your hand? Okay, Claire and Eric, any questions? How we get the √2? Okay, lady. Okay, so now we are going to look at the questions below, okay? So it takes 4 steps to do these ones, okay? Because we need to consider the positive negative sign as well, okay? It's not just turning less than in the first quadrant. It's gonna move, right, to the second quadrant, third quadrant, or the fourth quadrant. And sometimes could be turning clockwise, sometimes could be counterclockwise, okay? So break it down into 4 steps. If you follow them, right, you should always get it right, okay? So this is called find exact value. Exact value is referring to these things, okay? This is called exact values. Okay, or side ratio, right? Those are the sides. right? Root 3 is the side, 2 is the side, you put them together, side ratios. And then the 60 degree, this is called the angle. So they will give you the angle, and then you need to find out what are the exact values, okay? Or the side ratios. So that's our goal here, right? So go over step by step here. Because they give you the angle, right? So your first step is to draw angle. Okay, because they give you angle, right? Given angle. Okay, so step 1, draw angle. So let's pick one questions, okay, to do it together. We'll do question E. So everyone, please draw the angle out, 150 degree. Okay, once you got the picture, please raise your hand. 150 degree. Raise your hand if you have the picture, okay, of 150 degree in standard position. Okay, so Nick, which quadrant is it?
Quadrant 2.
Okay, so let me draw it out. Quadrant 2, 150 degree. I'll put a terminal arm there. Okay, 150 degree. So that's your step 1, okay? Now step 2, once you got the picture, next step is to find out the reference angle. Okay, first step, draw angle. Second step, reference angle. Reference angle, the symbol is theta with a little r, okay? R for reference. So please look at your picture now and write down the reference angle on the side, okay? So once you got that, please raise your hand, okay? How big is the reference angle? Is there anyone forgetting how to find reference angle? Okay, raise your hand if you have the reference angle. Okay, Sophie, how big is the reference angle?
30 degrees.
Yeah, very good. Okay, 30 degree. Okay, reference angle is with the x-axis, this green dot. Okay, that's our reference angle. Remember the butterfly, okay, right here. Okay, this is all the places of the reference angle in different quadrants. Okay, Eric and Jocelyn, did you get the reference angle? Jocelyn? Okay, if you have any question, let me know. Okay, if you forgot how to find reference angle, right? Don't know why we get 30, let me know. Once you have the reference angle, and then we see, oh, it's a 30 degree, right? So 30 degree is one of the triangle here, right? It's either the green one, green angle, or the blue one, right? Power 6, power 3. Okay, so you look at this picture, 30 degree is the blue one. So you need to put the numbers into the right places, okay? Power 6 is the shorter one, right? The shorter side, smaller angle, shorter side. So you need to put in the 3 numbers into the picture, okay? So it's a 30 degree. So the shorter side is 1. Hypotenuse is 2. Adjacent is, I'm just gonna use same powder, okay? So it's not too messy. And then adjacent will be √3. Okay, so make sure you put the numbers at the right place. If it's 30 degree, its opposite side should be 1. Do not put √3. Okay, can you raise your hand if you understand up to here? So your step 3 is called side ratio. You fill in your sides. Okay, if you understand everything up to here so far, raise your hand. You fill in the sides according to the picture on the top, okay? But you have to memorize these pictures. The 2 triangles. Okay, Jocelyn, did you get everything? Write out the 3 sides. Okay, and then we want to find tangent, right? Tangent is what over what? Okay, Daniel, tangent is what over what?
Opposite over adjacent.
Okay, so you look from the reference angle, opposite over adjacent. What would it equal? Waylon? Look from the reference, opposite over adjacent.
Oh, can you repeat what you just said? I kind of cut out.
You look from the reference angle. Do you
Yeah.
know where the reference angle is?
Yeah.
Yeah?
Yeah.
Okay, so we want to find tangent. Tangent is what over
Tangent.
what?
Oh, one sec.
Which side over?
Opposite over adjacent.
Okay, so you look from the reference angle. So what number over
1
what?
over √3.
Yes, okay, so 1 over √3. So everything up to here is step 3. Okay, you fill in the sides and then you get the ratios. Okay, find the sides and write out the ratio. Any questions so far? Okay, last step. You need to check sign. Okay, sign means is it positive or is it negative? And to do that, you use the O and then sine, right? And then tangent and then cosine, right? The chart on the previous page. This one. Okay. I think in grade 11, you probably use a sentence, right? To memorize this. All students take calculus, right? These 4 letters. Okay, to help you remember. And remember S, sine, cosecant in the same place. Tangent, cotangent, same place. Okay, cosine, secant, same place. So we are in second quadrant with a tangent. Tangent in second quadrant. Positive or negative? Okay, if you know the answer, please raise your hand. Okay, tangent in second quadrant. Positive or negative? All right, so Philip, positive or negative?
Negative.
Yes, very good. Okay, who is positive in second quadrant? Callum?
Oh, sine and cosecant.
Very good. Okay, so everyone else will be negative. Okay, only sine, cosecant positive. So we know we need to add a negative sign to your ratio. So this is your final answer. Okay, so it takes 4 steps to get there. But of course, first one we go in so much detail, right? As you do more, it gets easier. Right, so draw angle, reference angle, side ratios, and then you check sine. Okay? Please raise your hand if you have no questions up to here. How to do the 4 steps. Okay, Claire, any questions? How we found -1/√3?
No, I just forgot to raise my hand.
Okay, right, so let's do another one. Okay, we have done tangent. Let's pick something that we haven't seen before. Okay, let's do cosecant. Cotangent, okay, cotangent. Yeah, cotangent. Okay, so question O, okay, on the next page. Would that be too challenging? 1140. It makes a lot of turns. Let me see. Okay, let's do something easier first. Okay, less turns. Let's do question N. Okay, same angle, but this time the secant. Okay, so I'll let everyone try this out. Okay, so see if you can carry out your 4 steps all the way till the end. Okay, once you have the answer, final answer, you can raise your hand. All right. Secant 150 degree. Okay, it's on the next page. Question N. Step 1, draw angle. This is 150 again, right? Step 2, write out the reference angle. Step 3, fill in the side and the ratio. Step 4, check positive, negative. Okay, first step, first 2 steps are the same, right? 150 degree, so it's still in second quadrant. Reference angle is still the same, 30 degree. If the reference angle is the same, then your sides are the same place, right? Okay, if you have the answer, please raise your hand. Okay, Evan, do you have questions?
Oh no, sorry, I thought I raised my hand.
No, okay. So what's your answer, Evan?
-2/√3.
Say that again.
-2/√3.
-2/√3, because secant is which side over which side?
Are you saying like hypotenuse over adjacent?
Yeah, hypotenuse over adjacent. Very good. Okay, second quadrant, secant should be negative. Okay, is there anyone who got it different and doesn't know why it's -2 over root 3? Okay, your homework will be something like this. Okay, you'll be practicing how to do these ones. Now we're gonna try something that's radian. All right, so let's look at a question that's radian. We have done secant, right? We have done the tangent. Let's do something different. Let's do a cotangent. Okay, so this is the first time we have the radian. Okay, so we're gonna help you with this one together, right? So question P. So when you get an angle like this, do not, I'll repeat again, okay? Do not change to degree. Otherwise, you'll be a few steps behind, okay? So you got to think in radian now. So we have 13 pi over 3, right? 13 pi over 3. So first thing comes to your mind is you look at here, we have pi over 3. So pi over 3 has got to do with how many degree? Eric, pi over 3 is how many degree?
Is it 60?
60, right? So we have 13 pi over 3. That means you have 13 times the pi over 3, right? You have 13 pieces. Oh, I wrote pi over 6. Should be pi over 3, right? 13 slices. Think about slice, okay? 13 slices of pi over 3. So when you draw the angle, okay? Pi over 3 means pi is 180, right? Over 3 will be like this. 1 slice, pi over 3, 2 pi over 3, 3 pi over 3, okay? You think about this way. Keep on turning. 4 pi over 3, 5 pi over 3, 6 pi over 3, 7, 8, 9, 10, 11, 12, 13. Understand how we count it? Okay, I'll count one more time. Okay, you see it's pi over 3, so you draw a picture like that. Right? Cut into 3 pieces on each half. Pi over 3, 2 pi over 3, 3, 3 pi over 3, 4, 5, 6, 7 pi over 3, 8 pi over 3, 9, 10, 11, 12, 13. 13 pi over 3. Okay, so 13 pi over 3, it should stop in the first quadrant. Okay. So go to here. Each side has 3 slices, right? So full circle is 6 slices. So it will be 2 circles and 1 more slice. All right. Can you raise your hand if you understand how we count the angle? Okay. So do not change the degree. So that's one way, right? One way. Or you can think of this way. If something like this big, right? 13 over 3, you can write it as a mixed fraction. Okay. 13 over 3 is same as 4 and what? 4 and 1/3, right? That's one way, right? So let me redraw it, right? So you can also think this way. We have 4 pi and power 3. Okay, make sure you write this down. 4 pi and power 3. So you have 1 pi, 2 pi, 3 pi, 4 pi, and a third. Okay, this will be faster, right? You turn it into half a circle to count. Okay, can you raise your hand if you understand the second way? Okay, so I would prefer, right? If the number is big, I prefer the second way better, right? Please raise your hand if you understand this one.
Wait, Jason, could you explain the second way again?
Yeah, second way is you look at 13 power 3. Then you look at the fraction part, just the number part, okay? The 13 over 3, can you change that into a mixed fraction?
Yeah,
What would that become?
4/1/3.
Yeah, okay. So that's why 13 power 3 is the same as 4 and 1/3 pi, which is the same as having a 4 pi and a 1/3 pi.
Oh, okay, thank you.
Okay, yeah, and then you just turn 1 pi, 2 pi, 3 pi, 4 pi, and then another power 3. Each pi is a half a circle, okay? Remember, each pi is not a circle, it's only half a circle. Okay, please raise your hand if you understand how we get a picture quickly. Okay, so we have our angle there, right? So that's your step 1, right? Step 1, draw the angle. Step 2, we need to get the reference angle. Okay, so write the reference angle on the side. Reference angle is the one with the x-axis, so we can see it's power 3 already, right? Is the red part, this red dot. Okay, because it makes 4 pi and then power 3 more, right? So power 3 is the reference. Okay, and then step 3 is to write out our ratio, side ratios. And remember, we are doing cotangent. Okay, so please fill in the sides, and then write out the ratio. Okay, raise your hand if you have your answer.
Wait, Jason.
Yeah.
For the 4 pi plus pi over 3, where did the extra pi come from?
Oh, okay. 4 and 1/3, right? It started with the 4 and 1/3 pi, right? Follow that part?
Yeah.
Yeah, okay. The 4 and 1/3, what this means is 4 plus 1/3. Got it so far?
Okay.
Okay, so that means the pi is for both. 4
Okay.
and 1/3, okay?
Okay.
Yeah,
Okay, thank you.
you're welcome. Yeah, I invite all kinds of questions, okay? Anything that's confusing, let me know. Otherwise, it will continue to bother you, right? Okay, if you have the final answer, the side ratios, please raise your hand. We're doing cotangent. This is in first quadrant, so always positive, right? You don't need to worry about the signs, positive, negative sign. Okay, let's check the sides first, okay? Angela, how long is the opposite? I cannot hear you.
Can you? Hello?
Yeah. How long is the opposite?
Is it one? Sorry, is it one?
No. Power 3 is the longer or the shorter side? Power.
Sorry, root 3.
Yeah, okay. Power 3 is the green one, right? Oops, right? The 60 degree. So you have to put the square root 3 on the opposite side. Okay. So sometimes you need to change. If the reference angle is power 3, then your opposite side should be root 3. If your reference angle is power 6, then the opposite side should be 1. Okay. So once you figure that out, it will be root 3, 1, and 2. Okay, everyone else, if you got the final answer, raise your hand. Okay, we're doing cotangent. Okay, Waylon, what's your final answer? Waylon? Waylon, are you there? Hmm? No, I cannot hear you. You didn't turn on your mic. Okay, Waylon? Still cannot hear. Oh, okay. Okay, I'll come back to you, okay? How about Daniel, what's your answer?
I got 1 over root 3.
1 over root 3, okay? So adjacent over opposite, okay? And then it will be positive in quadrant 1. All right, so everyone clear? Let's try last one, right? Let's do question R. Okay, this one we have a negative angle, right? Question R, cosecant, okay? And 27 pi over 4. So think about how you do it quickly. How do you turn it quickly? Do not change to degree, right? Work in radian. And remember, this angle is a negative, so you have to turn in the direction that's negative. Okay, step 1, draw the angle. We'll double check this one, your step 1 first, okay? Make sure everyone got the right place. So please raise your hand after you got the picture, okay? After you finish step 1, draw angle. (27 over 4 pi). Where does it stop? Okay, everyone, please raise your hand if you got step 1, the picture. If anyone has questions, let me know. And then after you raise your hand, if you are sure it's correct, you can move on to other steps, okay? This is the last example we'll do today, so make sure you understand how to get the answer, all right? So in the homework, please show all the work, like how you draw the angles, okay? So that way I can see which part is wrong, right? When you go back and try to fix your mistakes, you can find out where it's wrong. Make sure you show all the work for homework. Okay, Eric, have you got a picture yet?
Oh, not yet.
Okay, Callum, what's the 27/4 in mixed fraction?
I'm not done yet. I'm still trying to do it.
27/4. Change that to mixed fraction and let me know.
Okay.
Because it shouldn't take that long, okay? If step 1 takes 5 minutes, it will take 5 hours to finish your homework.
Minus 6 over 3 pi over 4.
So 6,
Yeah, minus 6. This is
negative
negative.
6, and
3 pi over 4.
make sure the pi goes behind, okay?
Okay.
Yeah, so negative 6 and 3/4 pi, okay? Pi, you put it at the end. So that means you need to turn. Okay, you can ignore the negative for the moment, right? Just remember the angle. You need to turn in the negative direction. 6 pi, right? So 6 pi, this is 1 pi, 2 pi, 3, 4, 5, 6. 6 pi and then 3/4 pi. Where would it stop? Which quadrant do you think it will stop in? 3/4 pi.
The second quarter.
No, not
I
not
mean, third
part.
quarter, third.
Third one, yeah. Okay. You think about pizza. Right? We are going to the bottom. We want to do power 4, right? 3 power 4. There'll be 1, 2, 3. Okay. So we turn 3/4 of a pi. Okay, pi is a half a circle. You want to turn 3/4 of it. So stop there. Okay, we are doing clockwise. So make sure it's negative angle, so you have to turn clockwise. 6 pi, and then continue 3/4 of a pi. All right, make sure you know how to get the picture. All right, step 2, reference. Okay, so reference angle is the one that's in the red part, the red dot, which is like the pizza slice there, right? Because you already turned 3/4, right? So the leftover remaining slice. So how big is the reference angle? Chris, how big is the reference?
45 degrees.
What's that?
45 degrees.
Radian. We have to do everything radian.
Pi over 4.
Yes, yeah. Okay, so you have one slice of pi over 4 left, right, in that pizza. Okay. So if you see the denominator is 4, then you know reference angle will be pi over 4. Okay, if it's like over 6, reference angle will be pi over 6. Okay, and over 3 will be pi over 3. All right, so it's a pi over 4, right? Fill out the sides. Okay, so please raise your hand if you got the final answer. Side ratio, check sign. Okay, please raise your hand if you got everything on this for question R. We're doing cosecant, okay? So think about cosecant. What over what? Positive or negative in quadrant 3? Okay, Nick, cosecant is what over what?
Hypotenuse over opposite.
Cosecant, hypotenuse over opposite. Yeah, okay. So the size here is 1 root 2. Hypotenuse over opposite should be what, Susan?
Root 2 over 1.
Yeah, root 2 over 1.
Neg-
Okay, and then we need to check the sign, right? So Daniel, what's the sign for this one? Positive or negative?
Negative.
Yeah, cosecant should be negative in third quadrant. So your final answer is just negative root 2. Okay, Kellen, Claire, Evan, and Justin, do you have any questions? How we get negative root 2?
No.
Okay. How about you, Evan and Justin? Justin, do you have questions?
No.
Okay, yeah, your homework will be like this, okay? So I will assign these 2 pages, okay? The one because we didn't do everything, right? So you can work on these ones. Just do it in the book, okay? For these, because you have space. So you can take pictures of these 2 pages, okay? And I'll mark them. I will also select a few more with radian. So like in the homework page, I will assign these 8 as well, okay? Those ones have radian measurements, okay? So I want you to practice radians, okay? So those 2 pages plus these 8 questions, okay? So if you have any other question, you can stay after, okay? And have a good weekend. I'll see you next week.
Bye, Jason.
Thank you,
Okay.
Jason.
Yeah.
Eric, Evan, make sure you hand in the homework.
Oh, I didn't have it in yet.
Eric, yeah, I don't see yours.
Oh, I'll go take a picture again and re-hand it in.
Yeah, it's not here. Okay.
Okay, do you mind if I leave first, or should I wait?
Yeah. Please hand it in before you go. Okay.
Okay, give me a second then.
Yeah. Susan.
Could you repeat what the homework is?
Yeah, I'll post them. Okay, but it will be here. This is page 61,
Uh-huh.
number 36, Q to X.
Okay.
Okay, and then did you get that down?
Yep.
Okay, and then the ones that we skipped on those 2 pages. So page 41 and page 42.
Okay, got it.
Okay,
Thank you.
welcome.
Bye-bye.
Bye.